All right, so after you memorize reaction reference sheets that was given in study guide 1, the one that we discussed earlier, now we are going to start with reactions. So I would highly suggest these reactions, work on it, and then you can check the answer. So how do you work? You should be able to write products for all reactions without using notes. You need to try them and make sure your answers are correct, and print out second copy with which you can make flashcards and write correct product on the back of these cards and shuffle them, and that way you try to memorize them and apply it. All right, now this is alkene, C double bond C, and HX and ether. So that is basically addition of HX, right? So if it is addition of HX, how this forms? So basically this double bond, one bond breaks, and that C is going to join with the Cl. In typical reactions, we saw that X is joined with that particular C. In here we have a Cl, so that is going to join. So what will be the product look like? CH3, CH, here Cl join, instead of double bond, single bond, and then CH3. So this is a product. All right, now again this is an alkene, C double bond C, 4 carbon chain, and Br2, so that is X2. So that is the what reaction it is. Let's think about it. Remember, it was addition of X2. So what was the product? Remember that 1x goes, this double bond breaks, 1x goes here, 1x goes here. So that is, instead of X we have Br2, so that is Br that is joined. So let's try writing them. CH3, C, H, CH, 1 Br goes here, 1 Br goes here, and then we have CH3. So this is the product that you can find. Now let's see here, same thing. It's Br2 and H2O. So that is halohydrine formation. Halohydrine formation. So that basically what will be the product? Remember that OH, this double bond breaks, OH join with one of this carbon, all right, and Br join with one of this carbon. So that is typical halohydrine formation. So when we write, we have CH3, C, CH, OH, and CH2, and we have Br. Okay, so that is halohydrine formation. All right, let's see. We have CH3, CH, double bond CH2. In this case, we have oxymercuration, water addition and oxymercuration. So I'm gonna write, so you can, water addition and oxymercuration. So in that one, when we write its product, we have CH3, CH, OH is here, and CH3. So that could be our product. This is, remember, BH3, hydroboration and water addition. So this basically typical reaction, when you refer to its water addition and hydroboration. And basically you can get this product CH3, CH2, CH2OH. Alright. Now this is hydrogenation because H2 and PD catalyst, so that is hydrogenation. Once you identify the type of the reaction, it's easy to write its product because that's the standard reactions. Once you memorize it, application is easy. Alright, so in basically double bond breaks and you can add hydrogen on each carbon. Alright, let's move. I'm gonna scroll up. Here you guys need to find out which one is the what type of the reaction is, and I'm gonna draw the product. CH3, CH3, double bond O. Alright, H2PD catalyst, hydrogenation, alkenes hydrogenation. And you can write its product. This is basically alkyne hydrogenation because 3 bonds, so that is, you can write the product. Now you know how to write. This is hydrogenation as well. Alright, I would say here I'm gonna write that. You can write. This is hydrogenation, and this is CH3, CH, double bond CH, CH3. So 3 bonds and 1 bond breaks, and then on each carbon you are adding hydrogen basically. Elimination. So basically nucleophilic elimination, you need KOH. In elimination, it is even reaction, and it's a CH2, CH, CH3. That is the product. So this is alkynes acid-base reaction. As soon as you see that, it's alkynes acid-base reaction. And you know that alright, you guys need to find out what kind of reaction is this, and you can apply. This is the product it forms. Alright, so basically if you memorize standard reactions, then you can apply in each different situations, and let's see if we can work on next one. Okay, I'm gonna scroll up. This is CH4 plus Cl2, so it's a CH3Cl addition reaction. This is NBSCCl4, so basically CH2 Br or Cl CH CH2, so it's addition again. This is alkene or alkyne 2HBr. So in this one again I would highly suggest to identify the reactions, and CH3 here. Alright, so instead of triple bond, 1 bond breaks, and that means that each carbon is, one is joined with hydrogen, one is joined with bromine. This is addition of X2 reaction. Now it's easy, Br2, and that we already discussed. And basically CH3 CH Br CH. So Br on each carbon, bond breaks between those, and CH3. This is water addition and hydroboration. CH3, CH2, CH2OH. Same thing, water addition and hydroboration. So when you see that reaction, Li and NH3. So I'm going to write that product. You guys need to identify the reactions based on your memory. Sometimes I write the type so it will easy for you. Sometimes I write products and you can identify the reaction. Alright. Again, this is oxidative cleavage. Most of these are oxidative cleavage. This is oxidative cleavage. This is oxidative. So let's see whenever this oxidative cleavage, in that one you should get C double bond O, and the other product is C double bond O H CH3. So that is oxidative cleavage. This is KMnO4, oxidative cleavage with KMnO4. So that is C double bond O forms, but only one, and H2O byproduct. This is oxidative cleavage of alkyne. This is for alkyne. This is for oxidative cleavage of alkene. So in that one you should get, and basically CH3 OH, C double bond O, and CO2. Again, you can refer to the typical one, and that way it will be easier for you all to understand. Now in here, C double bond O, CH3 OH, and CO2. This is the oxidative cleavage of alkyne with KMnO4. This is Mg ether, so that is Grignard reaction. Grignard reaction, and that basically you should get. This is Gilman reaction. Gilman reaction, and you should get CH3, CH2, CH3. Alright, substitution reaction. In that one, this is tertiary carbon, CH3, 3C, and nucleophilic substitution. This is the substitution reaction. For primary one, it's CH3, CH2, CH2, and U. In here it's HCl, so this one is, I'm gonna write the product, addition react, chlorine, CH3, this is just a single bond, CH2, CH3. So that way you can work on the products. Alright. Now let's work on some of those mechanisms. I'm not gonna, last two you guys are going to work on it. I'm gonna try to write couple of more, like C double bond C, H, HCl, and you can see these pairs of electrons goes here and that pairs of electron goes here. So basically it's carbocation forms. There is a carbocation. Carbocation forms, and then nucleophile is going to get attack on this carbocation, and that is basically addition reaction. Did I say nucleophile? No, this is addition reaction. Alright, now we are going to talk about Sn2 mechanism, even mechanism. Let me change the pen color. I'm going to select this color. Alright, so that is CH3 on 3 side and Cl on this one. CH3. Step 1. It's a slow, it's rate determining step. It forms carbocation. Alright, so you know that is carbocation forms. And then in step 2 is fast, KOH, and then you can see the alright, I guess I work on this one. Yes, I work on this one. We are going to work on this one on the other ones. So basically you can see CH3 and OH. So this is the step. Alright, we are going to work on this one this is basically Sn1 mechanism. Sn1. So this is basically Sn1. E1 we are going to work on it. Alright. So I'm gonna erase so that way I will have enough space so you guys can alright. So we worked on Sn1. We need to work on E1 reaction. So I'm gonna try and erase and get some space here. Okay. Alright, so E1 reaction we need to work and see. Let's say I'm gonna just add Cl, aqueous KOH. It's a slow RDS, rate determining step. Remember, slow is rate determining step. I'm gonna write a dash. This is a transition state. And then you can see OH, C, backside attack. So that is basically E1 reaction. Alright, so I'm going to scroll a little bit up. Sn2 mechanism. This is the one we are going to work on it. Alright, remaining 2 you guys need to work on it. You guys are going to find out on your own. So let's say this C is attached with X. This is coming out R3. This is inside R2, R1, and nucleophile. When nucleophile attack this carbon, and it's just a one step, Sn2 one step. This is wedge, nucleophile join, and you can see R1, R3. So that is Sn2 mechanism. So these are some of the mechanism. Now, last two you guys can work on your own. All right. Okay. Now the reactions become more complicated with more complicated starting compounds. So let's work on some of those. Here we have this is the compound CH3, CH, CH3, and Cl. This is the product, and how do we get that? So we have H3C, C, CH3, CH3, CH, C. So what two products would you get when you do this reaction with 3,3-dimethyl 1-butene? So this is 3,3-dimethyl 1-butene, and it reacts with HCl. You should get CH3 as tertiary, CHCl, and CH2H. This is 3-chloro, 2,2-dimethyl butane. That's one of the product, and the other one is H3C, C, CH3, Cl, C join with the CH3 and CH2H. The other product is 3-chloro, 2,2-dimethyl butane. You guys need to explain why and how for complicated, more complicated with more complicated starting product. Now let's see the other one. What 4 products would you get when you brominate 1-methyl 2-methylene cyclohexane with NBS in CCl4? Circle the major product. Okay, so all right, let's say we have here we get CH2, CH, CH2, and Br. Okay, now we have, let's see, this is and when 1-methyl 2-methylene cyclohexane under NBS, and the product it forms and let me change the color. This is 1, 2, 3. Okay, so the other product we get, now remember he hint that methylene substituent is double bond CH. Br, and that is, now in this one, let me change. This is 1, 2, and 3. The other product, all right, and double bond between 3 and 2, and this is Br, and when we count, remember it's 1, 2, 3. Okay, so that's the third product, and the fourth product is, okay, now you guys need to find out what's the major one that you get. Okay, so these are some of those hints. What two products would you get when you do the E2 elimination reaction of 2-bromo 2-methylbutane? Circle the major product. Okay, so let's start with here. CH3, CH, CH3, and this is Br under KOH, elimination product, which is CH2, CH, CH3. That is the elimination product, E2 elimination. Now when you look at here, we have, I'm trying to draw fast, this is CH3, CH here, 2-bromo 2-methylbutane. All right. And in that one, this is OH minus, and OH minus accept the proton. Remember, it's E2 elimination. It is given, it accepts H, and proton acceptor, basically, that you know. OH is proton acceptor, and so the product it forms 3 isomers, basically it forms. So I'm trying to draw the products. Okay, let's see if it fits here. I'm trying to draw some of those, not all. C, you guys can, not here, there is no branch here. All right, and you get Br minus 1, H2O, so it's 2-bromobutane. That's one of the product. But 1-ene. All right. Then the second one, let's see if I have some space. And I would highly suggest that memorize all the reactions and work on your Connect assignments. And this review is not enough. You need to work on your LSA assignment, CA assignment, and end of the chapter problems. It's a cis-and-trans butene. So this is but2-ene, and then the cis and trans. I don't have space here. 2-ene. So those are 3 isomers. So that's something you guys need to apply and, work on it. All right. I'm going to scroll up. Another way to practice reactions, make your own study guide with information below, including examples. So remember addition reaction. So there are sample reaction, electrophilic addition to alkene of HX, X2, HOX and water by oxymercuration, Markovnikov's. Then you do electrophilic addition of alkenes of HX and water by oxymercuration. Other additions are hydromorations, catalytic addition of H2, catalytic addition of H2 through Lindar catalysis, and catalytic addition of H2 with Li and NH3. Then elimination reaction, dehydrohalogenation E1 and E2. Substitution, Sn2 general, Sn2 alkene alkylation to glow a chain, Sn1 general radical substitution. Chlorination of methane, NBS allylic bromination of alkene. So those are some of those you need to, again, this is organic 1 review. This is not enough. You guys need to work on your Connect assignment, LSA assignment, the study guides, and review all the topics. I would highly suggest sample reactions and memorize those. So this is end of study guide 1.